So yeah, first I'll give a brief introduction to what topic models are. So it is basically a unsupervised text analysis technique. So for example, we have millions of documents in our text data and we don't even know what to search for. So that's where we can use topic models. Yeah, for example, we have a newspaper corpus and using topic model, we can get a brief overview of what our corpus belongs to. For example, using this technique, we can get an estimate that our corpus belongs 41% to election, 25% to wars, and so on. Like, this is just an example. So, yeah, but the way that technique works is, it doesn't give us the direct labels that, like, it won't give that it belongs 41% to election. It rather gives a list of words, a group of list of words. So for example, our technique gives the list vote, party, campaign, and candidate, and we'll ourselves have to infer from that this group of words can belong to a topic election, and yeah, so on. So that's how topic modeling works. And so yeah, in gensim we have simply a one-line implementation for this. Like, there are different types of topic model algorithms, but the most popular one is LDA. So yeah, this is the API we use in gensim to train our topic model. But yeah, like, earlier there was no way of knowing when to stop the training or when our model has been sufficiently trained. So this summer I added a visualization interface as part of my GSOC project with gensim. So it basically plots the evaluation metrics as the training progresses live on the browser. Like, I use the Visdom library for that. Have anyone heard of Visdom? It has been recently open sourced by Facebook. So in competition of, you can say, TensorBoard. So yeah, I used Visdom for that. And these are the, yeah, these measures are the typical evaluation metrics that has been used to evaluate topic models. So I just made the interface to rather visualize them during the training. So yeah. And next, I'll talk about some visualizations which can be used to analyze the output of topic models. So yeah, but this is how the output looks like in gensim. So there's the API.showTopics, and we can define how many topics we want to see, and it gives us a list of tuples. And the okay. The first part of the tuple, for example, in first case 0, that's the topic number, and the list of word defines the top words in that corresponding topic, and the number which seems to be multiplied in front of them is the weightage of that word. So for example, in first tuple, the topic 0 has 0.3 weightage of word people, 0.2 of Trump, and so on. So this is how output looks like in gensim. So yeah, now we come to the visualizations. This is a very popular visualizations which has been used for analyzing topic models. It basically, I'll show it in the browser itself. Yeah, so let's talk about the left panel first. It plots the topics, like, yeah, the circles represents the topics and they are plotted according to their intertopic distances. So like the closely, yeah, the topics which are plotted closely are semantically similar. For example, we can see that if I hover over this topic, can you see the words, list of words in the right panel? Okay. Yeah, it basically belongs to American politics if we want to summarize this topic. And if I hover over next one, there are many similar words basically belonging to American politics only. So that's how it plots closely related topics together. And yeah, the area of the circle defines the proportion of that topic in our corpus. So for example, we can see that topic number 11 has the biggest size, and it belongs to, mostly related to American government, and so that's the most prominent topic in this corpus. And this corpus is the fake news corpus, if anyone have heard of it. It's available on Kaggle, so it makes sense to it belongs to politics majorly. And in the right panel, when we select a topic, the right panel shows the top words that belongs to that topic. And as you can see, there's a slider also above this right panel. It is basically to adjust the ranking of words. So as it has a range from 0 to 1. So if we select the 0, it shows us the words which are completely exclusive to that selected topic. So for example, first I'll explain what the red and blue bars means, because that the red bar basically means that the word has this much of proportion in that topic. For example, for first word, we can say that it has 55% of proportion in red color comparative to the complete bar. So this word has a 55% proportion in topic 11, and the blue bar, or we can say the complete bar, is the frequency for whole corpus. So now we come to the relevance metric. If we select 0, it shows us the words that are completely exclusive to that topic, and that's why we get the ones with complete red bars. And as we go further, it changes. And if we choose 1, it completely shows the words that belong in general sense to that topic. So the drawback in the extreme values is that the extreme values of 0 and 1, that in case of 0, we might get completely rare words that we don't even know about. For example, it might be a name of some person or place, so we won't be able to comprehend our topic from that type of word. So the 0 value is not suggested, and so is the case with 1. It can give us very generic words that might be there in every topic. So then the problem is that we can't differentiate between the separate topics. So the suggested value is 0.6, like it was mentioned in the paper which introduced this visualization. So and as we see in this case, it plots the intertopic distances on the left panel, but there might be a case when we want to see the exact distance between a topic pair or some topics. So we can also use a heat map for that. On the heat map, the x-axis and y-axis both represents the topic, and in this case we have total number of topics as 35, and if we hover over a block, the first thing is the x. It defines it means topic number 31. y topic number 9, and z is the value of distance between them, and the list of words which is there after the 3 plus signs is the intersecting words between these two topics 31 and 9, and the list of words after the 3 minus sign is the different topics. So like we can see that what is the exact difference between two topics, and like what exactly are the intersecting and different words which are inferring to that distance value. So yeah, this is the heat map one. Okay. Yeah, the next visualization is topic networks. Sometimes we have topics which might correlate to each other. For example, we have interdisciplinary subjects. So in that case, it can be useful. I'll show it in the. Yeah, in topic networks, the node represents the topics. For example, yeah, if we hover over a node, the first thing is the topic number, and then the list of words are the top words that belong to that topic. And if we hover over a edge, it shows us the intersecting and different topics between the two nodes that the edge is connecting. So yeah. Dendrogram. Yeah, so the next one is topic dendrogram, and sometimes we get a use case that we want to cluster our topics in a hierarchical form. For example, if we have a newspaper corpus, it has different sections, for example, belonging to sports, education, entertainment, and in sports we can have further different categories belonging to football, cricket, and so on, different sports. So yeah, for example, our the most higher hierarchy represents the newspaper corpus, and then it differentiates into the sections like sports, education, and entertainment, and then we can get even more subclusters. Yeah, for example, in sports, as I said, the different types of sports. So that's where the dendrograms are useful. And if the x-axis values defines the topic number, and the y-axis values define the distance between the clusters. And if we hover over some meeting point of any cluster, we can see the similarly the intersecting and different topics between them. And the next thing is, using topic models, we can also get the topic distribution of our each of our documents. For example, in our corpus, we usually have different documents. So we can get the topic distribution for each and every document. For example, in this case, we can get the result that it belongs 50% to politics, 30% to weather, and yeah, so on. Like gensim has a API for this also. I'll just show it. Yeah, so we can simply do our model dot get document topics, and in this case I'm getting it for each every document, but we can define the document number we want to get the topic distribution of. And yeah, this output shows the topic distribution of first document in our corpus, like the index is 0. So what it represents is that the first part of tuple is the topic number, and the second part, the decimal value, is the weightage of that topic in that document. So now we'll see that how we can utilize this to visualize documents also. So we can use the topic distribution of a document as its vector embedding, and then simply upload it to TensorBoard. Like this is the online TensorFlow, and we can load our vector files. There's an option on left panel for that. Like it is not showing up in the projector format. So, okay. So in this, the dots represent our documents, and for example, this was a visualization for a movie corpus. It has the synopsis of different types of movies, and so like each dot represents each document, and the label, this list which we can see after the label is basically the topic distribution. This is showing up the first 5 topics belonging to that document. So Alice in the Wonderland has 0.9%, it belongs 0.9 have a weightage to topic 4, and 0.002 to topic 1, and further. So but the problem with this visualization is that we might not have the document titles every time. Like this corpus has the synopsis and the movie title with it, but not every corpus has a title. So then we use the numeric IDs, but then the problem is that we'll have to correspond that if the label is document 1, then but what is document 1? And we'll have to refer to the CSV file, and that's not really a feasible option. So I'm actually working on another visualization which can show up the document content also on hovering over the point. So for example, right now we just see the label, but then we would also be able to see the content of the document. So that's it with the LDA projections. Okay, that's it. Thank you.
Okay, thanks very much, Parul. We've got plenty of time for questions, so that's here. So can we start?
So with the various tools for seeing what topic is, what words are characters to the topic, how often do you find that you look at a topic now, okay, yes, I can see what that, intuitively what that is, and how often do you just sort of think, actually, I'm still not sure what?
Can you repeat, like, I didn't get it right.
I guess with the tools that you've got to try to understand the topic and the words in it, like how often do you end up with kind of a topic that you kind of understand what it is? And do you sometimes just look at it and think, no matter how much I visualise this, it just seems to be weird?
How often does it do like clear-cut clustering, where you can actually see clearly defined clusters? Because that's always, if you ever do a course on these things, you do it and you get like, and look at this example I showed you, like this neat cluster of things that tends to fit together. How often does that happen, or how often do you seem to do it?
Not that often. We sometimes get redundant results also when the topics are not really comprehensible, and Yeah, in pyLDAvis, for example, it's not always that the related topics are plotted together. So yeah, that does happen. Yeah.
Is that one? Yes. Yeah. Any more questions?
Yeah, are there any automated techniques to try and infer a category label for the topic?
I don't know about it. Yeah, there might be, but like I don't have an idea. Okay.
Just play around with tech support a little bit. How are you finding that? It's quite new technology, isn't it? How are you finding using that? Because I think just from like helping to visualize how some with neural networks how they're working, I find it's really helpful. You can get on it, you can click on it, and just sort of see how the architecture things fit together.
I didn't use that part. You're talking about the network graphs thing and not the embeddings.
Oh, right.
Okay, yeah, like the one which is used to visualize neural networks graphs. Yeah, I didn't use that one. I just used the embeddings one.
Okay. Looks like we can be the first to keep it coming. So we'd like to thank Parul again.